Hey guys, welcome back to another video. Today I have a question or a review packet sent in by a student that I have about geometry. So we're gonna go through it. Looks like a lot of stuff about skew lines, perpendicular lines, solving missing angles, things like that. So without further ado, let's get straight to it. Okay, so the first question gives us a cube that looks like this, and it asks us a few questions about things that are coplanar, things that are perpendicular, and things like that. First things first, let's kind of like define what those mean. So coplanar is basically meaning that it's all on one particular plane. So the way that I like to think of a plane is almost like a saran wrap, a very fine sheet of paper, but imagine it going infinitely. Does everything match on that sheet of paper? So for example, my hand, everything on here is coplanar. Imagine like I take my hand, go like this, almost like I'm a mime, right? Now I'm going like this. All this stuff here is coplanar. But now let's say, for example, I take it and I step back. Notice that there's one thin sheet of paper almost in front of me, and then there's one back here. So those are two different planes, and that goes everywhere, right? I can go like this. Now that's a plane, right? A thin sheet of paper going like this. I can even ones go like this, like almost like here. All of these things are just thin sheets of paper that go infinitely, create a plane. So the first question here, are the following parallel, perpendicular, or skew? So first thing I have is segment FD and HC. So I got FD right here and I got HC right there. So what those are gonna be is they're gonna be parallel. The reason why is because notice they are going in the same direction but in different places. So they're going right next to each other and they're never gonna intersect. But in order for something to be parallel, they have to be planar. So how are these planar? Well, imagine if I draw something like this. Now notice all of these are on this type of plane like that, right? Again, it's almost like this type of plane, where if I draw that thin sheet of paper right in between them right there, that's the plane that they are on. So they are parallel because they are going in the same direction, so they're never gonna intersect, and they're on the same plane. The next two ones I have is ED and AB. Are those parallel, perpendicular, or skew? Well, let's go through them. Parallel means that they're going in the same direction and are never gonna intersect. Well, this one looks like it's going up and down, and AB looks like it's going side to side. So they're not, right? They're not going in the same direction, so not parallel. Perpendicular means that they're gonna intersect specifically at a 90-degree angle. Well, again, these aren't gonna intersect, so they're also not perpendicular. So that leaves skew. And in this case, skew is correct. The reason why is because skew are two lines that are non-coplanar and they're not parallel. In this case, well, they're not parallel because one goes this way, one goes that way. That's not parallel whatsoever. And they're not planar because notice if I draw this thin sheet up and down here, right? It's gonna be like this. And I have another one back here that's like this. Those aren't on the same plane, right? I can't draw a thin sheet of paper that's gonna connect them both perfectly. So in that case, that means that these are completely skew. That would be the answer for that one. All right, the next question is ABD and GEC, parallel, perpendicular, or skew? Well, again, parallel means that they will never intersect and they're going in the same direction, right? So in this case like this, well notice, look at this one on top. If I drew it out infinitely, it's gonna be like the horizontal plane, right? It's just gonna be like a table. And the GEC is just directly below that. Again, horizontal plane. So in that case, parallel. All right, I got three other questions based on this that we're gonna go through. First one being, are A, F, D, and E coplanar or non-coplanar? So A, F, D, and E, well, I got A, F, D. Those are all coplanar because they're on top, but E's on the bottom. And can I draw a thin sheet of paper that covers all of them perfectly without it bending or crinkling? No. Because I got this thing on top and then it's got the bend down to get to E, which means that those are in fact not all coplanar. Okay, next one is asking me name the intersection of HC and CE. So where do they meet? Well, HC is in the back, it's that segment right there, and CE is right here. So they're intersecting at point C. And then the last one here is ABD and then DBC. Where do they intersect? Well, they don't intersect at a point because those are two planes, right? They're not segments, they're planes. So they're gonna intersect at a segment, which is gonna be this segment right here, DB. ABD is gonna be this one up top right here. DBC is just gonna be this one on the side right here. Where are they touching? They're touching perfectly right here. Segment DB would be the answer for that one. All right, next question, I'm provided this with two parallel lines, cut with a transversal and I have to find this side here. So anytime you guys have a parallel lines like this that are cut by a singular line, there's a lot of rules that we can apply here, and I'll go through a bunch of them. So the first one that we have is vertical angles. What vertical angles are is angles that are directly across from each other through a vertex. So look right here, I got a vertex right here. Notice that this angle is directly across from this one. Some might say vertically across. Anytime you have vertical angles that are directly across from each other, they're always the same. There is another rule that we have that are called alternate interior angles, same side interior angles, alternate exterior angles, same side exterior angles. These are all types of rules that we can apply when we have parallel lines like this. Anything interior means that it's on the inside. So if you notice here, these two lines, there are numbers on the outside, which are the ones above and below the lines. And then there's these angles in here, like this one, this one, this one, and this 53 degrees right here. See, like if this was a house and it's raining, if you're inside here, you're chilling, right? This is your floor, this is your roof, you're good. If you're on the outside right here, you're getting poured on, right? And I don't know, maybe this is like some Stranger Things thing and it's like the upside down. You're getting poured on this way as well, right? Either way though, you can see the difference between the inside and the outside. So in this case, since I have 53 degrees right here, I'm dealing with interior angles. Now, same side interior angles, just like the name states, are angles that are on the same sides, this one and this one. The relationship between these are, this one is 53, this one must be 180 minus 53. It's the remaining value. This one, however, these are alternate interior angles, and their relationship is the same relationship that vertical angles have, where they're the same. So this one is 53. Quick tip. Anytime you're dealing with parallel lines, there's only two possible answers. They're either the same or they add up to 180. It's one or the other. So you'll notice as I go through this thing, there's only two possible numbers that are gonna show up on this, and it's gonna be 53 degrees and 180 minus 53 degrees. I have 53 degrees here. Some of you are asking,
what about the relationship between these angles, right? Wouldn't that be faster?
That's true. I just wanted to show you this relationship here. But these angles are called corresponding angles. Corresponding angles are essentially the same exact angle in different spots. So notice in this case, 53 degrees and 53 degrees. Those are both in the top right. That means they're corresponding, right? It's like the same exact thing, just in different spots, right? We can call them like twins or something like that. The last one, which is the most important one in my opinion when it comes to geometry and solving these things like this, are linear pairs or supplementary angles. Supplementary angles or linear pairs are angles that add up to 180. Supplementary angles are a more broad version. They just have to add up to 180. Linear pairs need to be in a line. Notice that if I draw this angle right here, it creates a line. Right? They're both on the same exact line. If I add them together, it creates this. That makes them a linear pair. So in this case, if this is 53 degrees, this one right here is 180 minus 53 degrees. And in that case, well, 180 minus 50, it's 130, minus 3 more, it's 127. So that is the answer to this, but I want to show you guys how this works. Because from here, I can even find all of them. For example, in this case, this is a linear pair with this one, but look, it's also vertical here. That's 53 degrees. I could have also used alternate exterior angles. See, they're on alternate sides and they're both on the exterior to find this. Now, in this case here, these are same side interior angles. I could do that. I could say these are, in this case, a linear pair. I can use that to say that this is 127 degrees. It's also vertical to this angle, right? From here, 127, 127, these are alternate interior angles. I can use that. And this is vertical to that one. See, there's like an infinite amount of ways that I can use to kind of bounce around to get all these answers. That's completely up to you. Whatever your eye sees, you'll start figuring that out the more and more you do these. But again, pretty cool. Only two possible numbers. And again, this is me being kind of like a test prep teacher rather than a tutor. You can kind of see which angles look the same and which ones don't or look different. So if you're on a test and you're not sure, if this angle is a small angle, right, and you look across and you don't know what this is, well, is it a small angle too? Yes, then it's got to be 53 degrees because the only other option is the larger angle, which in this case, if it's not that, you know, it's one or the other. You got a 50-50 chance. All right, here's another example here. So one thing that I want you guys to notice here is that, like I said last time, a lot of these only work if they are parallel lines. If they're not parallel, for example, then that same side, alternate interior, all those types of things go out the window. They don't work. So we have to be really careful here because we are given a set of parallel lines, but we're also given a set that's not. So for example, I'm gonna break this down into almost two questions. This question right here, and this question right here. And the reason why is because these parallel lines are related because they're cut by a transversal here. And these are, which are related, but notice that these are not parallel. So the correlation between these two is not the same. So for example, I cannot do this one right here because these are not parallel. This one is not a corresponding angle here. I can't say that this one's also equal to angle 3 because these right here are not parallel. So now, what type of angle is that with this one? Well, notice they're both on the top left. What does that mean they are? Corresponding. Corresponding angles are equal to each other. So that means that angle 3 is also known as 101 degrees. Now these two down here, what type of angles are these? Well, these are same side exterior angles, which we didn't go over. So let's just say you have no idea what that means. Well, we do know that this right here is a linear pair, which means that if this is equal to 92 degrees, this must be equal to 88. Well, what type of angle is that with this one? Notice these are both where? Exactly, in the bottom right, which means that this also has to be 88 degrees. So now for this one, we're gonna use those same ideas, but now we have variables included. So what I gotta do is I first gotta solve for x, and then I'm gonna use that to find angle 4. The reason why is because right now I know that 12x plus 2 and angle 4 are corresponding, meaning that these angles are the same. So what I'm gonna do is I am going to try to find a way to solve for x, which means I have to figure out the relationship between these two angles, right? Because if they're equal to each other, I'm gonna set these both equal to each other. And if they add up to 180, well, I'm gonna add them up and make them equal 180. So how am I gonna do that? Well, if I know that this angle is equal to this angle, because they're corresponding, and I know that angle 4 and 5x plus 8 are linear pairs, can't I just say that 5x plus 8 and 12x plus 2 must then be linear pairs? Does that make sense? I hope so. So in that case, if 12x plus 2 is equal to 4 and 5x plus 8 is equal to 180 between these two, then these must also equal 180. So what I'm gonna do is I'm gonna set that up. 5x plus 8 plus 12x plus 2 is equal to 180. From here, I'm just gonna solve. 5x plus 12x, I forgot to write the x, but just imagine it, 17x. 8 plus 2 is 10. Equals 180. I'm gonna subtract 10 from both sides. I get 17x is equal to 170. Divide both sides by 17. X is equal to 10. Now, is this my answer? No. Because again, I'm trying to solve for angle 4 here. So what I'm gonna do is I'm gonna plug it back into 12x plus 2. Why not 5x plus 8? I mean, I could, and I would find the answer anyway, but this one's a lot more efficient because I know that 12x plus 2 equals 4. So 12, replace that with 10, plus 2. Well, 12 times 10 is 120, plus 2, and that equals 122 degrees. All right, this question here, again, ignore the drawing, it's a little wonky, but all I gotta do is I gotta find angle 1 and angle 2. So I'm gonna use all these rules that we've been going through again, right? All these rules are gonna be used no matter what, probably through this, just some more creative in different ways. The first thing that I'm noticing here is I got a little triangle and I got a big triangle, right? This thing looks like a candy cane or candy corn or corn candy or kettle corn. I don't know. You know what I'm talking about, right? The Halloween thing. And the most important part about that is it's telling me that these triangles are similar. What similar triangles tell me is that they're proportionally related to each other. So for example, if I have a small triangle right here and all sides are 2, a similar triangle would be a big triangle where all the sides are 4. Notice how it's just 2 times as big? That's a similar relationship. Another thing that tells me though, which is gonna be important here, is the fact that the angles on the inside are the same. Just keep that in mind while we're solving this. So the first thing that I'm noticing, linear pairs. Remember, I said linear pairs are gonna be like the savior for us. It's the most important one. So I need to get inside this triangle to find these. So my first entry right here is gonna be 138 degrees. So 138 degrees, that means that this one on the inside here has gotta be 180 minus 138. Let's do some math here. Cancel, borrow, this becomes 10. 10 minus 8 is 2. 7 minus 3 is 4, 0. So in other words, this is 42 degrees on the inside here. Now remember what I said. What does it mean if they're similar triangles? It means the angles are the same. Well, bingo, bango, bongo right there. If this is 42, then this must also be 42 degrees because they're similar.
And then you're like, Jaden, I don't understand that, I don't understand that.
Well, let me help you out. Let me prove it to you. Notice if I expand this out and drop this down, see how now I have two parallel lines? And more importantly, these parallel lines have been cut by this transversal of a line right here. So that means that this angle and this angle are corresponding because they're both in the top right. See here, top right, here, top right. So that's the reason why. Next one I gotta find is over here. So how am I gonna do that? What type of angle is this related to this? Well, it looks like I'm looking through a vertex, correct? Exactly. These are vertical angles. And now how is that gonna help me? Well, I have 42 degrees and I have 74 degrees. Another thing that we haven't talked about yet, but is important, is that the sum of all of the interior angles in a triangle must add up to 180. That's just a thing, it's got to. So in that case here, I can find this one, this top one right here, by just subtracting. So let's first do 42 plus 74. 2 plus 4 is 6. 4 plus 7 is 11. So I get 116. Then I'm going to do 180 minus 116. Again, to find that missing angle, this one on top here. Well, you can't do 0 minus 6, so I come over and borrow. This becomes 10. 10 minus 6 is 4. 7 minus 1 is 6. This becomes 0. So this top angle must equal 64 degrees. Okay, so now I know that these are all good, right? We're all chilling. I need angle 2 right here. Or yeah, I need angle 2. How am I going to find that? What I'm noticing is, again, this smaller triangle's coming in clutch. The sum of the interior angles must add up to 180. So what I can do here is I can take 64 and 42 and add these together. I'll just do that right now. That's just 106. And then if I do 180 minus 106, that's got to give me this final angle because the sum of the interior angles must add up to 180. So in this case here, you know, all that borrowing, whatever, blah, 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 that's going to give you 74. Again, we could have used, if we wanted to, that idea of corresponding angles. I just wanted to kind of show you how all these things work out all together. And then the last thing that ties it all together, how am I going to figure out angle 2 given all this stuff? My best friend, the linear pair. So now, last but not least, it's just 180 minus 74. Cut this thing off, put down a 1. 10 minus 4, that's 6. 7 minus 7 is 0, and then a 1. 106 degrees. Right here. And there you have it. All right, this next question here is asking me, what is the relationship between segment or line L and line M parallel? Why or why not? So anytime you have those two lines right there, they're just looking next to each other like a couple of breadsticks or an 11, something like that. That means parallel, that's what it means. So how am I gonna figure this out? The same rules that we've been using so far forward, we can use them backwards. Now you're being like, what do you mean by that? The fact that parallel lines allow me to use, you know, alternate interior, same side exterior, all those things, well, we can work that in reverse, meaning that if same side interior and alternate interior, all the things are not being respected, then that means that the lines cannot be parallel. So what I can do is I could just solve it this way. Well, let's use corresponding angles, for example. Corresponding angle would be right here. Notice that these are vertical, which means that that's not a way, right? That's not possible. Okay, if that doesn't work out for you, we can even do this, for example, 65, this is vertical with this one. And now these are vertical, or these are corresponding. See, they're not. That means it's not parallel. I could even do something like this one and this one. These are linear pairs, which means that this is 65. This is 180 minus 65. So 115. Well, 115 is corresponding with 115. And does this add up to 180? Nope. So that's another reason why they're not parallel. Again, that's a bunch of different ways to show the same thing, but the general consensus is if this does not match up, then it means it's not parallel, because by the law itself, by the rule, all of those properties, all of those theorems must be able to be used or must be abided by if these are parallel lines. All right, so next question here. Which lines are parallel between R, N, P, and Q? And what they're gonna do is they're gonna give us some like certain situations, and we're gonna have to determine it using the rules. So question A, given that angle 1 is congruent to angle 2. Well, if angle 1 is congruent to angle 2, does that prove which lines are parallel, and if so, which ones? Well, if angle 1 and angle 2 are congruent, that is telling me what type of thing? Well, it's telling me that these must be some form of corresponding angles, because notice that they're both in the top right. Well, remember, parallel lines, let's say if I go like this. Congruent angles are gonna be like, for example, this one here and this one here. Notice how they are connected to the two separate parallel lines. Boom and boom. So that means that if this is the case, if they are in fact corresponding, which it's telling us, that means that in this case, we can prove that they're parallel lines. And in fact, it's gonna be R is parallel to N. Okay, next one, we got angle 3 now is congruent with angle 1. So now I got these related to each other. So you guys might be thinking,
Oh, well that means that something is congruent because those are alternate exterior angles.
wrong. Remember, if I draw this again, alternate exterior angles are the ones that are on alternating sides, but they're connected to the same line. They're always connected to this transversal here, which is the line, and they're based on the two parallel lines. But notice, there is not one single transversal that they're connected to. They're in fact connected to two transversals right here, R and N. So for that reason, I can't prove anything is parallel. This one says angle 4 plus angle 6 equals 180. We got these right here. So first things first, are they connected to a single transversal? They are. So rules are possible. Next thing I'm gonna advise you to check is, do same side interior angles add up to 180? So let's check, right? Let's say, for example, you can plug in numbers, right? Let me plug in numbers in this case. If I plug in 50 here, well, that's corresponding with this one, which is 50, making this one 130. Well, 130 plus 50 is 180. So in fact, that is true, that same side interior angles, right? Notice that they're on the inside of R and N. Same side interior angles do add up to 180. So now that is true. So now the question is, which ones do they prove are parallel? Remember, the ones that they prove are parallel are the two lines that they're connected to, not the one transversal that they have together. It's the two lines that they're connected to. In that case, again, it's R and N. So this proves that R is parallel to N. Okay, last one here is angle 3 is congruent to angle 2. Okay, so same thing. Are they connected to a single transversal? They are, N. Okay, now, are alternate exterior angles equal to each other, right? They say they're congruent, are they? Well, let's see. And what I'm gonna do is, in this case, I am going to use numerical values. So let me just start with this one. Let's say this is 50. If this is 50, this is a linear pair with this one, which makes this 130. If this is 130, this angle up here is corresponding, which makes this 130. And in that case, 130 is a linear pair with this angle over here, which makes it 50. So notice that I got 50 on the top, 50 right here. That means that they are equal to each other, which does prove that there are in fact some rules that are applying here, right? These are in fact parallel. Now, which ones are parallel? Well, again, they are connected to the transversal N, but so then we just look at the two lines that they're also connected to separately, which is P and Q, which means that this one proves that P is parallel to Q. All right, so now this question is saying that AE, this symbol right here means perpendicular, perpendicular to GC. Find angle ABD. Well, the first thing, anytime you're given something like this, or they give you like something that's given or something like that, we have to ask ourselves, what does that mean? What is the significant? Well, anytime AE is perpendicular to GC, so something is perpendicular to something else, what that's telling me is that there's a right angle somewhere. So if I look at AE and I look at GC, that's telling me, oop, this is a right angle, and that also means that this is a right angle. So now the next thing I gotta do is, provided here, what's the relationship here? Well, notice these are vertical angles. Well, what are vertical angles? They're equal to each other. So that's what I'm gonna do with these two things right here. So I'm gonna get 2x plus 12 is equal to 4x minus 18. And now I'm just gonna solve. So I'm gonna add 18 to both sides. Right, I could subtract 12, but I'd rather keep things positive. Okay, that's gonna give me 2x plus 30 equals 4x. Now I'm gonna subtract 2x from both sides. That's gonna give me 30 equals 2x. And then I'm gonna divide by 2. And it gives me x is equal to 15. Now, if I wanna find ABD, what I'm gonna do is I'm gonna plug in the 4x minus 18. The reason why is because if I know that this is 90 degrees right here, I know that this is just the remaining value of whatever this is. So if I plug in 15 times 4, so 4 times 15 minus 18. Well, 4 times 15 is 60 minus 18. Well, 60 minus 20 I know is 40, so minus 18 must be a little bit more, so 42. So that means that this is 42 degrees, which means that this remaining value has to sum up to 90. So in other words, 42 plus the remaining value of x is equal to 90. I'm gonna subtract 42 from both sides, which means that in this case, ABD is gonna be equal to 48 degrees. Okay, so this question here is asking me to find the measure of each angle and classify. Well, I'm not given any actual numerical values, I'm not given any angles, but I am given something. I'm given that this is a triangle. What are the sum of the interior angles of a triangle? 180. Exactly, so that's what I'm gonna do here. I'm gonna say 4x minus 5 plus 2x plus 12 plus 4x plus 3 must equal 180. Again, math is a language, right? So I'm translating. I know the sum of all the interior angles must equal 180, so if I just say this angle plus this angle plus this angle must equal 180, let me just translate that. From here, let me simplify. 4x plus 2x is 6x plus 4x is 10x. Negative 5 plus 12, well, that's 7 plus 3, that's 10. Equals 180. So I'm gonna subtract 10 from both sides. I'm gonna get 10x equals 170. And then I'm gonna divide both sides times 10. Dividing by 10 is the same thing as just cutting off zeros in this case. So I get x is equal to 17. So from here, it's just a plug-in game, right? So let's just do this bottom one right here first off. Well, 17 times 2 is gonna be 34. Plus 12. Well, 3 plus 4, or 3 plus 1 is 4. 4 plus 2 is 6, so this is 46. Okay, well, 17 times 4, that's gonna be 68. Plus 3, well, 9, 10, whatever, 71. And now I can plug it in here. I'm gonna do that in this case, but you really wouldn't have to because it's just 180 minus the sum of these two angles, but let's just do it in this case. 17 times 4 again, well, that's 68. But now 68 minus 5, that's gonna be 63. And just for the sake of it, let's add it all up and let's see if it equals 180 in the first place. So 63 plus 46, well, 3 plus 6 is 9. 6 plus 4 is 10, plus 71. 9 plus 1 is 10, you carry the 1, 0 plus 7 is 0, plus 1 is 8, and then 1. 180 degrees, well, you ought to look at that. Now, it says classify the angles. Well, all of these are acute angles, and how I know that's because they're less than 90. They're all acute, they're all small, so each one of these is acute angles. That's how I'd solve this one. Okay, so this is question number 10. In this case here, I have to classify the triangle and I have to find x. So in order to find x, I need to figure out the relationship between all these x values. Well, I do have a triangle, and I know that the sum of the interior angles is equal to 180. But I'm not given this angle. Wrong, I am. Remember, this is a linear pair. I told you this is gonna be our best friend. It's not giving up on us just yet. So that means that if this is equal to this is just 180 minus this. Let me do that. So 180 minus 6x plus 16. Well, the first thing that I'm noticing here is what's 180 minus 16? Well, 180 minus 10 is 170, minus 6 is 164. Now remember, you have to distribute the negative. So this isn't just gonna be plus 6x now, this is still minus, so minus 6x. So in other words, this angle right here is 164 minus 6x. Now I have the sum of the interior angles, right? I got all of them. So now I'm just gonna add these all up. 5x minus 10 plus 2x plus 6 plus 164 minus 6x. Now imagine this is equal to 180. I just don't have enough space right now, so let me just combine like terms real quick. Well, 5 plus 2 is 7, minus 6, that's just x. 164 plus 6, that's 170, minus 10 is 160. So 160 is equal to 180. I subtract 160 from both sides, and I get x is equal to 20. Part 1 complete. Now I have to classify the triangle. And the way that I would do it is I would plug in the x into each one of these. Now, looking at it, again, this is like the test prep teacher and me, not the tutor. Looking at it, this is not an obtuse triangle, right? I don't have any wide angles. It's possible that's a scalene triangle, so all the angles would be different. But what I'm noticing here is this is pretty small, this is pretty small, that's a little bit wider. So what I'm thinking is this is either some sort of acute triangle, like an isosceles triangle, or it's a right triangle. Well, right triangle, I have to plug it in here, right? And also you can kind of think about it. If I plug in 20 here, I get 100 minus 10, that's 90. There it is. In this case, it is in fact a right triangle. Now, obviously I have, hindsight's 20/20. So if this was your first time seeing the question, you would just plug in 20 into each of these, see what your angles are given, and then classify the triangle accordingly. Okay, so now this question is asking me, or telling me that the perimeter is equal to 56. It wants me to solve for x and wants me to classify the triangle. So this one is a little bit different because I'm not given the interior angles that equal to 180, I'm given the sides. Well, still the same idea though, because perimeter, what is it? It's just the sum of all the sides. Well, perimeter is 56, let's get to it. 4x plus 2 plus 2x plus 7 plus 6x minus 7 is going to equal 56. So 4x plus 2x, that's 6x, plus 6x, that's 12x. And 2 plus 7, that's 9, minus 7, that's going to be positive 2, so plus 2, equals 56. So what I'm going to do from here, I'm going to subtract 2 from both sides. I'm going to get 12x equals 54. And then I'm going to divide both sides by 12, and that's going to give me x equals, well, this goes in 4 times, 48, and then 6 remaining, so 4.5. So now from here that I got x is equal to 4.5, it wants me to classify the triangle. Bet that, I just plug stuff in. So 4.5 times 4. So in my mind, I'm thinking 45 times 4. So that's 180. So then if I do 4.5, that just is a decimal move, so 18, and 18 plus 2 is 20. So this side is 20. 4.5 times 2, same regard. 45 times 2, that's 90. Decimal move, so 9. 9 plus 7, that's 16. I have to plug it in here. Well, 4.5 times 6, I'm thinking 4.5 times 2. I know that's 9, and I have to do that 3 times, so 9, 18, 27. So 27 minus 7, that's also 20. Notice I have 2 sides that are exact same. This is an isosceles triangle. And that's going to be it for today, guys. I hope you guys enjoyed this. I hope it was interesting, something new, or maybe even helps you on a test that you're having coming up yourself. If you have questions similar to this, always feel free to let me know in the comments. You can also email me those questions, things like that. But without further ado, I'll see you on the next one. Take care, and as always, peace out.